Dr. Matt Levin. I'm a cardiac anesthesiologist in the Department of Anesthesiology at Mount Sinai Hospital, and here today to talk to you about some of the innovation that we did during the COVID crisis around ventilators and sharing ventilation. Um, the background of this is that in early March, when cases were starting to rise, there was a real concern that we were not going to have enough ventilators to ventilate all the patients who were coming into the ICUs. This had to do with the fact that typically we don't keep a lot of spare ventilators on hand. They're expensive, they need to be maintained. And the surge that we were seeing, we were going from, having maybe on a typical day, a couple of dozens of patients in ICUs throughout the system to hundreds of patients in ICUs. And we didn't know how this was going to play out. So there was this idea that started to circulate on the internet, and it was an old idea that had been tried before during some mass casualty situations of sharing ventilators, so using one ventilator to ventilate more than one patient. And suddenly, with the looming shortage of ventilators, it got revived. So Dr. Rich, who is the president of Mount Sinai Hospital, formerly chairman of anesthesiology, and one of my own personal mentors, approached me and said, can we figure out this, how can we share ventilators? So that started an incredible about month and a half of innovation, which saw a lot of people come together in our department, as well as throughout the institution, to try and come up with a solution that we never actually ultimately had to use, but we wanted to have available. So it all started with a Zoom meeting, I think at the end of March, and we talked about what we had seen in the literature, and we knew Columbia was doing some stuff, and came up with a sketch or an idea of, if you were going to share a ventilator, which means having two patients with two breathing circuits connected to one machine, how do you regulate the flow that goes to each patient? Number one. Number two, how do you keep the patients separated or isolated from one another so there's no cross-contamination? And number three, how do you deliver along with flow, some individualized tidal volumes? Because these patients were very sick and had different ventilation requirements, although in general their ventilatory requirements were very extreme, much more so than you see in most normal intensive care patients. So starting from that, that was maybe on a Thursday, I want to say, towards the end of March. And then the next day, Mike McCary, who is the head of perioperative services, so that means he runs the operating rooms, he said, well, you should really talk to these guys from Stryker, because they're very innovative and they have these great manufacturing capabilities. So I said, okay. So on Saturday, we arranged to talk to Stryker. But meanwhile, before that, we said, well, what could we do that would be off the shelf right away? Can we do something? So we had settled on the idea that we should use some sort of valve that we could dial down and limit the amount of flow. And so we started looking on the internet, and this was myself and maybe 4 or 5 different anesthesiologists. We started a WhatsApp chat group at 10 o'clock or 11 o'clock at night, and we're going back and forth. And we realized, and I'm going to reach for my into my cabinet, we realized, oh, well, there's these plumbing valves that you can buy that happen to be almost the exact correct dimensions or diameters to fit breathing tube circuitry. So we literally went to Home Depot and we started buying plumbing valves. And this is just it's called I think a gate valve. So I don't know if you can see that as I turn this, there's a little gate that sort of starts to close. And so normally this is used in your house to shut off the water supply to your sink or whatnot. They come in a couple different colors, sort of different styles, but they're all the same inside. So we bought a bunch of them, and the Department of Anesthesiology, we have a simulation lab with these high fidelity patient simulator mannequins that are, they look like a person. and they're connected to a big machine, and they can breathe, and they have a pulse, and they blink, and they have a blood pressure, and when you do things to them, they respond. So we had this amazing laboratory to experiment with. So we started building circuits out of plumbing parts and rigging things together. And separately later, I'll share or can be distributed our protocol, which has the pictures of the initial prototype circuit that we had made. So literally, we were sitting there and doing this and hooking it up to two patients, two dummies, and showing proof of concept that we could actually control the ventilation going to the two different patients by dialing down this, and that it worked and that it would fit in the circuit. Now, this obviously was a very crude solution, and we wanted to immediately start to iterate. Nonetheless, we did go out and buy about 600 valves from a plumbing supply store, so that we had them on hand. Couple $1,000, so not, sounds like a lot, but in the context of the crisis, not that much. So then meanwhile, so that Saturday I had a call with Stryker and struck up an incredible partnership with these engineers from Stryker who normally work mostly on neurosurgical projects, so products, so stuff for implantation in the spine, spinal fusions, this type of stuff, but kind of got the blessing from Stryker management to start devoting some of their time to trying to solve this problem. So we talked about, what we were looking for, and they said, okay, well, let's do some sketch. We have some 3D printing facilities, and so we have a 3D printer in the department, and also there's Sinai Biodesign, which has a 3D printer, but Stryker has 3D printers on a whole different scale. So they're industrial 3D printers that can print out of much higher density or quality materials, and much finer resolution parts. So we sketched out what we want, and the next day or by Monday, we got sent our first prototype of an actual control valve, and it looked like this. And it basically was the same thing, where there was a pathway, and let's see if I can open it. Now with a much smaller hole, it's really probably impossible for you to see. Actually, you won't see it because the channel looks like this. But with a rather than the gate valve, it was what's called a needle valve. So this is a plunger essentially, which is more appropriate for airflow versus fluid flow. And so we took this and we got it in a couple different sizes, 9 millimeters, 11 millimeters. Started playing with them and said, yeah, this works. Okay, cool. And simultaneously, we were working to develop a protocol. I joined a Slack group that was a worldwide Slack group on differential ventilation. And we had seen the protocol from Columbia, which we took and started to adapt. We were working simultaneously with the pulmonologists who were trying to adapt BiPAP devices to be invasive ventilators, and they had come up with a protocol. So on the one hand, the team was working on a protocol. On the other hand, we were working on a valve design. So that was the first design, and we rapidly iterated to the next design. And so then this may be a little bit hard to see, but we started to improve by adding some notches, indicators. There's much more fine detail in the valve. You can't really appreciate it, but it has click stops. Still comes all the way out. Looks fundamentally the same inside, has an O-ring, whatever. But the engineers started to more appropriately shape these connectors. So it turns out that for breathing circuits, even though it looks like it's just a straight connector, they're actually slightly tapered so that breathing circuits press fit together and don't fall apart. There's actually an ISO standard for that. So we found that, and the standard specifies the diameter and the taper and everything. And so that was great, but still kind of like, sort of a little bit hacky looking. And very rapidly, within a week or 2 weeks, we had this. And all of a sudden, this is starting to look like a real piece of medical equipment, and it's marked. If you can see, it's a bit hard to see, but it has markers indicating sort of stops and the number of turns. It has better, these connectors are all the correct size, and again, inside, it's basically, now it's a much shorter stem that fits in. And so the breathing circuit goes here, the patient circuit comes out the bottom. And again, I'll share you the diagrams in the article. But and so, while that was all going on, then we were also trying to figure out, well, how do we actually test this? Because we were repeatedly testing it in the simulation lab, but we wanted to test it on patients. The ICUs were slowly filling up. We were at, I think we peaked around 75 or 80% vent utilization. So people were getting nervous. So we wanted to test it. And so then now we began collaborating with the intensive care, the ICCM, which is the Institute of Critical Care Medicine, and some med students and residents, mostly of anesthesia, to try and help identify patients that we could actually try this on. And so then that brought a whole nother set of issues, which was, is this ethical? Is this legal? Do we have permission? Do we have, permission to do this? So we began to have a lot of conversations with the IRB, Glenn Martin, with legal counsel for the hospital. They reached out to the state of New York, to Howard Zucker, who's the commissioner, talking about, can we do this kind of stuff? Basically then got the blessing of the state that, these devices and split ventilation could be used as a last resort in what they call the crisis standard of care, where basically you're in some sort of healthcare crisis, so you can do things you normally wouldn't do, that might not always be appropriate or approved in a normal time, but it's okay because otherwise people will surely die. So we got that. And also in parallel with the lawyers, we were working on what's the agreement with Stryker. We were doing everything on good faith, but we were trying to make an agreement that protected Sinai and this and that and the other. So then, but simultaneously, again, we're going, so now basically this had been like a prototype printer, and now they sent it to a production printer, and we ended up with this. And this is made with this super high quality, dense material that you would just not be able to 3D print on a home printer. And it's got this incredible detail. And this is all printed, which is kind of unbelievable because, I mean, there's a lot of, and this actually has a click stop. This has a stop on it, so it doesn't come out anymore. You could break it and come out. And this was actually R4, revision 4. And so we did all that, and then we identified some patients. And so then sometime in the early April, we basically, late at night, we wheeled 2 patients into a room and put on full PPE, myself and my lead colleague, an intensive care and cardiac anesthesiologist named Marty Chen. So we were fully gowned and masks and face shields and sitting in this room with these 2 very ill COVID patients and basically hooking up 2 patients to 2 circuits and disconnecting and reconnecting, and then ran this for an hour. And after that, and we did it for an hour and it worked. And so that was amazing. And at that point, we stopped because we felt like we had proved our point and it was hard to justify continuing it. So, it worked. And subsequently, we had the final version, which I showed you, which this is basically the production version. So it has all the appropriate markings on it. We created documentation. Reach onto my desk. We actually created the fact sheet, and this is the actual instructions for use. I mean, this was incredible. And I found out, I was actually catching up with the Stryker folks yesterday, and at its peak, they had 65 people working on this. I had only interacted with about 3 or 4, and I thought that was it, but there was a tremendous number of people because to generate all these things like this instructions for use, there's all this regulatory issues with it. There's a graphic artist and a copywriter. There's people to actually produce this, so to print it. So it was a massive mobilization of resources, of which I only saw the tip. And we culminated and we got the EUA, and we never ended up using it, which is a relief to most people. I was personally a little bummed because I was pretty confident in how it would work, and that it would work for a long period of time. But it did require a lot of monitoring. You really had to have an anesthesiologist or someone who was very educated in this do it. We actually did do user acceptance testing. So because I was working with Stryker, they knew the whole protocol or series of steps that you have to do to get a medical device to market. And so we did, what normally would take you 9 months or a year or 18 months, we did it in like 3 weeks. And it was incredible, a really incredible experience to see that happen, and just all this stuff, user acceptance testing and the documentation and the instructions for use. So it was an incredible experience. And by the end of April, the surge was coming down, and we didn't have a threat of running out of ventilator capability. So we ultimately never used them in a real situation, but still have them. I have 2 boxes of, I have like 100 pair of valves around. We published an article in anesthesiology describing it. I get emails about it. I just got an email from someone in Germany who wants to test them. Um, there was a group in Ireland who had developed a similar solution for splitting ventilation, but with a different kind of valve. So they wanted to test it. So then Stryker actually has production facilities in the UK. So they printed valves over there and gave them to the Irish guys. And so it was really pretty cool. It was worldwide. It was a lot of innovation in a very short time. It was super fun to do. It brought a lot of people together in our department who, because I'm cardiac, I don't normally work with a lot of the general anesthesiologists. So I got to work with a lot of people that I normally don't work with, and then throughout the institution, and then Stryker. So it was a great experience.